Welcome back. In the previous lesson, we discussed about the formation of ionic compounds, wherein two atoms are involved in the loss and gain of electrons, thus forming the ionic compound. In this new chapter called carbon compounds, we will be discussing about the formation of a completely different compound. So let us get started. If you look at the word carbon compounds, a compound is a substance that is formed when two or more elements they combine chemically. For example, you have an element magnesium, it combines with another element oxygen, you get magnesium oxide. So when two or more elements they combine chemically, we get a compound. In this lesson, we are going to discuss exclusively about compounds formed by the element carbon. So let us first get to know a little more about the element carbon. The element carbon, it has the atomic number 6. The electronic configuration for carbon would be 2, 4, meaning the innermost K shell is completely filled, whereas the L shell, it has got 4 valence electrons. Carbon, of course, it is a non-metal, and the position in the periodic table, carbon, it belongs to second period and 14th group, therefore it is a non-metal. Now, carbon is a very important element because carbon is one of the most important element which makes up almost all the living substances. Each cell is made up of carbon, therefore living organisms or living things are entirely made up of carbon along with some other elements like hydrogen, nitrogen, oxygen, phosphorus, sulfur, etc. So carbon, it forms the basis of life. Even though the percentage of carbon is negligible in the atmosphere as well as in the terrestrial forms. In the atmosphere, carbon is present around 0.03% as carbon dioxide, carbon monoxide, etc. Whereas in the terrestrial, on land, carbon is mostly found as carbonates and bicarbonates. Most of the carbon is trapped in water, once again as carbonates and bicarbonates. Even though the amount of carbon by means of percentage is negligible, is very small, the importance of carbon is huge. This is because carbon literally it forms millions of compounds. Carbon forms millions of compounds which are of structural and functional importance. Let us look at how or what property of carbon makes it possible for it to form millions of compounds. Let us once again come back to the electronic configuration. The answer to this question lies in the electronic configuration. So, how does carbon form compounds with other elements, since the lesson is about carbon? Now, in the case of carbon, there is a peculiar problem. The electronic configuration of carbon is 2, 4. We know that in order for an element to become stable, it needs to have a noble gas configuration or a octet configuration. Now, carbon has 4 valence electrons for carbon to attain the nearest noble gas configuration or stable configuration, carbon can do two things. Number one, carbon can gain 4 electrons. So, if it being a non-metal, that is what we expect. If carbon gains 4 electrons, then it would have a completely filled outermost shell. But in the event carbon gains 4 electrons, it forms an anion. What happens is carbon will have 6 protons, but it will have 10 electrons. This makes the element highly unstable because it is difficult for 6 protons to have a control over 10 electrons. The nucleus is not able to hold on to the extra additional electrons, making it unstable. So this possibility is ruled out. The next possibility is carbon should lose 4 electrons. If carbon loses 4 electrons, and then in that scenario it becomes a cation, which is highly unlikely, because in order to remove an electron from its shell or orbit, it requires energy. Now, as soon as you, let us say, remove 1 electron from the outermost shell, what will happen is the nucleus will have a more stronger hold over the valence electrons. The attraction between the nucleus and the outermost electrons will increase. So, in order to remove another electron from the outermost shell, the amount of energy required is almost double or triple. So, this is what we call it as first ionization energy, second ionization energy. So, let us say another electron is also removed from the outermost shell. Once that happens, the third ionization energy and the fourth ionization energy are very, very high. So, it is impossible to remove 4 electrons from the outermost shell of carbon. Why? Because large amount of energy is required to remove electrons from the valence shell. With great difficulty you can remove one, whereas it will be very difficult to remove the next electrons. So, because of these two reasons, carbon can neither gain 4 electrons nor it can lose 4 electrons, because it can be either unstable or it is almost impossible. So, to get out of this situation, what carbon does is carbon shares its electrons in the valence shell. Carbon goes for sharing of electrons. So, let us see how exactly does sharing of electrons take place. We will start with simple elements, then we come to carbon. It is not that only carbon is involved in this sharing of electrons. Other non-metals, other elements are also involved in sharing of electrons. Let us start with the simple example of hydrogen. Now, we know that hydrogen atomic number 1, so it has got 1 electron. Let us represent this in the form of a electron dot structure, which we already studied in the previous chapter. So, the 1 electron is represented as a dot, and once again, for it to be stable, it needs to either lose the electron or gain the electron. So what does hydrogen atom do? Hydrogen atom, it cannot lose or it cannot gain electron. It goes for sharing of electrons with another hydrogen atom. So there is one more hydrogen atom. So this hydrogen atom requires one electron for attaining a noble gas configuration. Similarly, this hydrogen atom also requires another electron. So they go for sharing of electrons. This sharing of electron is shown as a overlap between the outermost shells. So when the outermost valence shells they overlap, what happens is sharing of electrons takes place. This is what we show it in the form of this structure. As you saw, in the formation of ionic compounds between a metal and a non-metal, there is transfer of electron. The electron is transferred. It will lose and another element will gain. Whereas in this case, electrons are not lost, electrons are not gained. By sharing of electron, it simply means that this electron, it belongs to the electrons, the shared electrons. They belong to both elements, and this happens because of overlap of their outermost shells, overlap of the orbit or shells. Because of this overlap, these two electrons belong to this hydrogen atom, these two electrons also belong to this hydrogen atom. Therefore, the problem of gain and loss is overcome and sharing of electron takes place. In this case, one electron pair is shared between the two atoms. So there is one pair of electron that is shared. This can also be represented as, instead of the two electrons, it can be shown as a line connecting the two hydrogen atoms. So when two hydrogen atoms come close together, when the outermost electrons are shared, what happens is they form a bond. So this bond will hold the two atoms together, and thus we get hydrogen molecule. So two hydrogen atoms, they combine together to form a hydrogen molecule. What happens is sharing of electron takes place. So this is represented by a line. This is nothing but a bond. So one hydrogen atom, another hydrogen atom, when they come close to each other, their outermost shells will overlap, electrons are shared, and this results in a force of attraction between the two atoms as a result of this sharing and overlap. So there is a force of attraction, that is what we call it as a bond. This bond is called as a covalent bond, which is different from a ionic bond. In ionic bond, the bond is formed between a cation and an anion due to transfer of electrons, due to gain and loss of electron. Whereas here, covalent bond is a type of bond formed between two atoms due to sharing of their valence electrons. So the bond formed between two atoms due to sharing of an electron pair is called as a covalent bond. Because there is only one pair of electrons that is involved in this bond, we can call this as a single bond, because there is a single pair of electrons involved. Let us look at some other examples also to understand covalent bond a little more better.